Hello everyone. Today we will we will discuss compound interest, future value, and present value using business mathematics, chapter 9. It is owned by this particular PPT is owned copyright by McGraw-Hill. Okay, we can start here. First of all, I'd like to mention to you the objective. There's about 6 objectives in this particular chapters. Calculate the future value and present value using compound interest applications. Number 2, calculate the maturity and compound interest guaranteed investment certificates. Number 3, calculate the price of strip bonds. Number 4, adopt the concept equation from compound interest to compound growth. And number 5, calculate the payment. And calculate the payment on the day any date that is equivalent to one or more payments on other dates. Okay. Number 6, calculate the economic value of a payment stream. What is compound interest? Compound interest means that interest is calculated on previous interest amount as well as principal. The interest is earned on one period itself, earned interest in the subsequent periods. Compound interest tends to be used for longer term time periods, more than 1 year. So it is very common in finance. Okay. In terms of compounding period, what is compounding period? It is the time interval between successive interest conversion date. It is called compounding period. The number of compoundings per year is called the compounding frequency. We will use extensively for the remainder of this book. Excuse me. Let me just grab a sip of water. So what is the compound interest that is normally quoted? It is a number of the annual or nominal interest rate. Okay. Number 2 was stating the compounding frequency. Compound interest rate is normally quoted using a number of annual or nominal interest rate and stating the compounding frequency. Example, 3.5% compounded semi-annually. How are we going to calculate here? Compound interest is normally quoted with a number of example here, 3.5, which is the nominal interest. This is the nominal interest rate, okay? And then what is compounded semi-annually? This is the compounding frequency. So that is the difference between compound and nominal interest and compounding frequency, okay? There's it, there we go. Okay, let's move on to the next one. This is compounding frequency and period. What is annually? Annually means it's 1. Here, compounding period 1. Semi-annual is 2 here, compounding per year. This is 6 months, compounding period every 6 months. Quarterly is 4, compounding period is 3 months. Monthly will be 12, this is compounding period will be 1 month. Daily will be 365, this is per day. So the basic concept of this is basically simple. From year 0 to 03, 1,000 is the normal way. Its compounded will be first year will be 1,000 to 100, which is the first year of 100, and then beginning principal will be 1,100 the year 2, and 110 in the second year. Okay, third year will be 1210 at the beginning, and the interest earned will be 1 to 1. So this is the concept is like this: 1,000 from the beginning become the end, the end become the beginning here. Okay. So the compound interest result in progressive larger amount of the interest being earned. So how are you going to calculate this? So we're going to look at this on the one that I previously explained. 1,000 is 1,000 plus 1,000 times 10% times 1. So got 1,100 year 2 1210, which is here. And then 1210 at the end here become the beginning here, year 3, because 1331. Beginning at the end of year 3 become the beginning of year 4, 1331. Exactly 1464.10. So it's continuously based on first year is compounded from 1,000 become 1,100, 1,100 become 1210, 1210 become 1331, 1331 become 1464.10. So that's the concept here. Okay, look at the compound interest notations. PV means present value of principal, future value, the future value of our maturity value, N, which is the number of interest periods, M is the number of interest period for conversion period for the year. GM is the nominal interest rate that is compounded every time per year. And then I is the interest rate per conversion period, which is the JM divided by M. So I equal to J divided by M, where I is equal to periodic interest rate, such as 2% every 3-month period. J is the nominal interest rate, which is 8% compounded semi-annually. M is the number compounding period, which is 2% semi-annually. So when you go calculate here, exactly how you're going to calculate 10.5. So we're going to look at this step by step from A, B, C, D. So we're going to look at step by step. A, which is I, which is J divided by N. 10 divided by 1, which is 10.5. Okay, I is a 10.5. Okay, 2. Okay, annually. 10 point coming from here, annual is coming from there. Okay, second one, 9.75 divided by 2%, divided by 2, because 4.875 for I. For C, 9 divided by 4, because it's coming from here, because quarterly is become 2.25%. While for D will be 9.5 divided by monthly, which is 0.7916%. Okay. N equal to number of years times M, where N equals the number of compounding period, M is the number of compounding per year if they semi-annually. Okay, this is an example given to you, 9.1. Calculate the number of compounding period. How many times compounding is done when you completed $100 for 3 years at 6% annually. Okay, and 6% semi-annually or 6% quarterly. All right, let's look at the N, number of years times compounding frequency per year, equal to N times 3 times 1, which is 3. And then, where do you get the 3 years coming from? 3 is coming from here. It's on because it's annually, so you got the 3 there. Okay. And then for the N, here 3 times 2, because it's 3 years. Where's the annual is coming from? Because semi-annually, while the 4, the C1 will be, the C1 will be times 4, okay, 12, okay. Okay, let me just go back again here to original place. All right, let's go into the next one. You invest 4 years annually, so you're going to start here. J is equal to 6%, M is equal to 12, N is equal to 4 times 12 equal to 48. Then where you got coming from? 4 is coming from here. Where's the 12 coming from? Is annually, it's monthly here. Coming from here, 12. Okay, so you got a 48. Then you got the I coming from here. I equals 6% divided by 12, which is 0.5%. Okay, and then look at this skill check number I. For nominal rate 5.9%, determine the compound frequency if the periodic interest rate is 1.475%. What is I? Number 2, what is the periodic rate interest if the periodic rate is 1.5% quarterly? For the number I, the answer will be M equal to 4. Okay, for number 2, the answer will be 6% quarterly. Okay, 1.5 times 4, which is 6%. Okay. All right, let's look at the future value here. Next one, future value is a combined principal and interest due at the maturity date. What the logic for the formula value will be future value equal to the present value in bracket 1 plus I in close bracket equal to M. So what is the detail? FV, which is the future value, PV, which is the present value, I is the periodic interest rate, N is the number of compounding periods. So look at the example here. The maturity is 5,000, invested 4 years for 6%. So you're going to plug in a number. PV is 5,000 from here. 4 is coming from here times 12. 12 is monthly. You get a 48. I equals 6% of 12, you get 0.5%. So when you get this detail, you're going to plug in the number of this formula. 5,000, close bracket 1.05, close bracket 48 exponential. You get the answer, which is 6352.45. What will the maturity value of 5,000 invested for 4 years at 6% compounded monthly? The maturity will be the same thing, 652.45. So when you go into the detail of the calculator, you're going to on and off here. Okay, you're going to start business calculator on and off. Okay, you're going to plug in the number, which is 5,000 equal to times here. Okay, close bracket, and then 1 coming from there. 0.05 close bracket is coming from here. Okay, and then go where the y-x, which is for the exponential, which is 48. Okay, 48, then the equal to and you get the number of 6352.445. Okay, that's how you do it, the logic for it. Okay, let's look at the next one. This is your skill check. For this skill check, number 1, number 2, number 3, what will be the maturity value of 3,000 invested for 5 years at 12% compounded monthly? Okay. Number 2, calculate the future value of 7,000 invested for 20 months at 5% compounded quarterly. Number 3, what will be the maturity value of 4,500 invested for 380 days at a 3% compounded annually? The answer for this is actually at the back side of the presentation. Number 1, the answer will be 5450.09. Number 2, 7604.40. Number 3, 4641.69. Okay. Other things, another example here. Other things being equal, would the investor prefer interest rate of 4.8% compounded monthly at or 4.1 compounded annually for 2 years investment? So choose a value of present value, say 1,000 compared to each of the two rates. Do the timeline. So you're going to do the timeline here, 0, 1, and then 2 years, 4.8% compounded monthly. What you're going to get is 1,000 present value, which is 4.8% divided 12. You get 0.4% here. Where you got 0.4% income is from 4.8 here, because monthly is divided by 12. Okay, 2 times 12, you get 24. The first option. Then you got plug in the number, you get 1100.55. That's for the first option. For the second option, you're going to do the same thing. PV is 1,000, I is 4.9% divided by 1, it is 4.9%, and 2 times 1 equal to 2. So the timeline, when you do the time, you plug in the number, you get 1100.40. So the difference is only slightly. One is 55, the other is 0.40. So the 4.8% compounded monthly is slightly better. Okay. Okay. Second example, third example is excuse me, 92C, which is George invested 5,000 at 4.25% compound quarterly. After 18 months, the rate changed to 4.75% compounded semi-annually. What amount will George have 3 years after the initial investment? So breaking the two step, so you're gonna have like this, quarterly and 4.7 semi-annually. The first one is 5,000 for 1.5 years, 4.25. Okay. After 18 months, the rate change become 4.75 for the second half. So there's two components. For the first 18 months, we have the following: 5,000 I equal to 4.25% divided by 4 equal to 1.05% equal to n equal 4 times 1.5% equal to 6. For the second portion, the maturity after 18 months will be, plug in the numbers, will be 5,000. Plug in the numbers, you get 5327.34. Okay, that's how you get this. Then we look at the logic, the second one. Okay, this is the second one after that. Okay, remember here, let me just go back to this is the first 8 months. Okay, the first 8 months, you got this first number one, you got these numbers, and you will go plug in the 5,000, you got these numbers. Okay, for the first 18 months. Okay, for the second one, you're gonna get the same logic here, which is 5327, 4.75 divided by 2, which is 2.375, equal to, and 2 times 1.5 equal to 3. And then the final result of the 3 years will be this much. Okay, 5327 times divide in close bracket 1 plus 0.2375 close bracket 3. So because you get 5716. Okay, there's you got, because this is the first one you get. Where did you get this number from? From the first slide, the first investment. This is the second one, you got the different compounded interest. Okay, your skill check here, I'm going to show it to you. I need to invest a skill check of 2,000 at 5.75%. Compounded quarterly after 3 years, rate change to 500%. What will be the amount after 4 years? So the answer will be for this one is 2497.81. So this is a typical calculations of comparing compound and simple interest. There is the future value equal to present value 1 plus I close bracket. This is the original principal here, interest on original principal, which is the blue one, and the orange one is interest on interest. So give you an idea, it's a sliding scale here. Okay, 12% is higher sliding scale. 10% is the B1, and then 8% and 6%. See, you guys have to do it that. The more compounded, the steeper the slide. Okay, this is an example of the compounded monthly and compounded annually. A compounded monthly is higher, compound in terms of steeper, is much steeper than compounded annually. The annually one is the orange one. Okay, this is another example of a claim court rule. Mrs. Peacock, she claimed that Prophet Islam have default 2 payments, 1,000 each. One payment was due 18 months ago, and the other 11 months ago. What is the appropriate amount for the court for the plum to pay immediately? The court used 6%. So one they could use 6%. The formula will be, the first one is 1100, is 1,000 here minus 18, and it's another 1,000 minus 11 because defaulted 2 times. Okay. You're going to look at this, you draw the line of a timeline. Okay, the first one is 18 months ago, and then the second one is 11 months ago. So you're going to you're going to look at the sum of future value 1 versus future value 2 and equal the sum. So you're going to look at the focal date there is 0 months. Okay, so once you put that, you got the numbers, you're going to find in the number, you got here 2150.33. Okay, remember the logic here, just do the timeline. The first one is minus 18, second one is minus 11. You plug in, you get 2150. This is your second skill check. The answer for this one is about 11 to 4.46. 11 to 4.46. Okay, guys. So the next one is present value. I'm going to close this chapter because it's going to be too long. I will divide this into 2 parts. So the first part will be on the future value. Second part will be present value. Thank you, everyone. Bye-bye.